Hi and welcome once again to the NCV Mathematics Level 2. Our topic today is all about hyperbola and how to draw it using the intercept method. In our first problem we have sketched the graph of y is equal to 4 over x plus 2 using the intercept and asymptote method. Now clearly we see that the graph is a positive graph, so if the value here over x is positive, we know for sure that the graph will be in the first and in the second quadrant. We now first have to find the intercepts, and once again we will look at the x-intercept, and for an x-intercept we make y equal to 0. So substituting that would be x over 4 plus 2, and in the place of y we put a 0. We can manipulate this, and the 2 goes over, becomes minus 2, and multiply by 2 on both sides. We'll remove the 4 over there, and we get minus 2x equal to 4. We can further manipulate this, and we take the 4 and divide by 2, and our answer is x is equal to minus 2. So that gives us coordinates of minus 2, which we calculated, and 0 for y, which we substituted in. That gives us one set of coordinates, and the other set of coordinates, of course the y-intercept, we make x equal to 0. Unfortunately here when we do so we get 4 divided by 0, which is undefined. We cannot find that answer. So that is an important point to remember, and this is also what we call the asymptote. So undefined, and if we now remember, that would mean there's an asymptote. We also know that we have a plus 2 at the end, so that plus 2 at the end of my equation represents my q value, and that would be the new x-axis. We will also put that onto the graph. Now to find another point, because remember we have to draw both sides of the quadrants, we use the formula square root of a, which is the part on top of the x, that's the a value, square root of a, and the other coordinate will be square root of a plus 2, because we got the q value is equal to 2. So our formula is always going to be square root of the a part as the one coordinate, and the square root of the second of the first part, and added to it the q value. We call this the point of intersection for the axis of symmetry, and this will allow you to find another point, because you need 2 points. Because you can't find a point here, there's an undefined part, we need to now take that formula and try to find another coordinate. So doing that, our a part is 4 square root of 4. Our a part is 4 square root of 4 plus the 2, which is the q part, and that will give us ultimately square root of 4 is a 2. Square root of 4 is 2 plus 2 gives me 4, and I have got my 2 coordinates now, minus 2 and 0 and 2 and 4. We are now going to use this information, and we can now sketch our graph. Alright, we've got our Cartesian plane over here now, and those 2 points on our calculations were, we've got a point that was minus 2 and 0. We will put that point on, and the other point was 2 and 4. Remember the one that we calculated. So we've got our 2 points over there, and also very important, we need to know that q is equal to 2, so y is equal to 2. Q value represents the y, and that would be now our new x-axis, because we have an asymptote. Asymptote means the graph must not touch this x-axis. If we are having a point there, it will already touch this axis, but that axis has moved up to 2. And when we do construct this graph, we will have now going through this point, not touching this y-axis, not touching that x-axis, same here, not touching that y-axis, not touching this new x-axis, and we will construct it in that way, and this is what the drawing must then look like. In our next the problem, we've got draw the graph of y equal to negative 3 over x plus 1, again using the intercept method. And before I start, I see my a over x part is a negative, so I know this is going to be in the second and in the fourth quadrant. Again, I have to find the x-intercept first, make y equal to 0. When we do that, we will find minus 3 over x plus 1 equal to 0. I can manipulate that and move the 1 over, becomes minus 1. Manipulate further, I can get minus x equal to minus 3, and that would be x equal to 3. My coordinates then calculated is 3 and 0. For my y-intercept, once again we will find a undefined asymptote, right, where we put the x equal to 0 and we have 3 over 0. We cannot find that. So in order for us to get more other values, we can take any other value. We remember now we use the formula, but this is another method. Instead of using the formula of a squared, square root of a, and square root of a plus 2, we now can use another value, like for example a minus 1, and put it into the equation. Y is equal to minus 3. We substituted a minus 1 plus 1. This is our q value. Remember, we know q is equal to 1. When we do that and manipulate, we get y equal to 4. So we got minus 1 for x, we substituted, we get an answer of 4. Gives us 2 coordinates we can use. You can use any other values, negative values, to get the other side of the graph, but the easiest one is minus 1 to use. So we get 2 coordinates of minus 1 and 4 that we calculated using a value of minus 1, substituting it into the x part of the equation. We are now going to look at drawing this graph on the Cartesian plane. Right, here we have our Cartesian plane once again, and the points that we just calculated was 3 and 0, and that's the point we are allocating here. And the other point we calculated by substituting minus 1 was a minus 1 and a 4. So clearly in my second quadrant and in my fourth quadrant, because of the negative sign of minus 3 over x. Again, we will first now also have to show the asymptote. We know q is equal to 1, so we draw a line by y equals to 1, a dotted line. This is my new x-axis, because that is cutting the x-axis, and we know a hyperbola cannot cut the x-axis, right? So there's always an asymptote. So if you do draw this, you will draw it close to this line, the y-axis, and close to this line, the x-axis, but never touching that. Same over here. There's your x line, never going to touch or cross this, and here's your y line, never going to touch or cross this. And so at the end, this is what my drawing will look like. Clearly there you can see the asymptotes not touching, and we only calculated these 2 points. And this is how we construct any hyperbola using the intercept method.